Hi, welcome to another video. My brother was asking some questions about the previously repaired SWA 1501. I'm looking at the output stage. So this is an NPN transistor, this is a PNP. These transistors have a slightly lower rating than the originals. These are rated for roughly 140-160 volts and 10 amps, not 15 like the genuine Toshiba ones on that amp. I've got a 2.2 ohm resistor on each base. I haven't got any 0.33 ohms on the emitters. So these are 0.47 ohms each. Here's my speaker, form of a 12 volt bulb. I've got plus 10 volts there on the collector, minus 10 volts here on this PNP collector. And at the moment, since this power supply does not like being driven by this power supply, I've currently got this one wired up to the base of this first transistor with my current meter in series with the power to the base. We can measure the base current and then look at the output current. So that's today's date, 27/11/23. For those of you who don't know, just for the beginners, this scenario, the way they're wired up, this emitter of this NPN transistor, this emitter will follow the voltage on this base, and this emitter will follow this base, minus half a volt drop across the emitter. So you can see I've drawn some little arrows for the base current. So on an NPN transistor, we need the base to sit above the emitter, more than roughly 0.6 of a volt across that junction. Same on the PNP. So on an NPN, we pass a small bit of current this way, goes through the base emitter junction, through that 0.33 ohm resistor on the amplifier, out to your speaker, that should be about 12 ohms on this 1501, down to 0 volts. And 0 volts on this amp is the center tap of the transformer. On the PNP side, you need to take current away from the base. So how do you get current away from the base? Well, if this speaker is tied at 0 volts on one side, you pull current this way, through again that 0.33 ohm resistor, through the emitter, through the base, down to some negative supply rail. So negative in relation to 0 volts. So current will flow that way on the negative half sine wave or negative going signal from your microphone, CD player, whatever, and a positive going signal on this side. So when your signal is going negative, so the bias current, to turn this on to actually enable current to flow, the bias current flows from 0 volts through the speaker, through the 0.33 ohm resistor, through the emitter, and we're taking power away from the base. As we get a small base current, our collector current will be a lot bigger, and the collector current will flow through the speaker down, straight down to -70. That's the collector there. And the reverse on the PNP, with a small base current, we'll get a larger collector current. This is what I'm going to demonstrate with my multimeter set to current, and we can have a look at the base current and the collector current and work out roughly what the gain is of each transistor. And this is a current amplifier, it does not amplify voltage. Right, so my plus and minus 10 volts is turned on, as I say, so plus 10 volts on that one, minus 10 here, two emitter resistors, the 0.47 ohm instead of 0.33, and we've got a bulb instead of a speaker. My 0 voltage point is the negative of this bulb. The meter is currently on the positive from this power supply. which is going to be driving the base of this upper transistor. Let's turn this up and watch the current over there and the current on the base. So you can see there we've got 0.7 of a volt here, and that transistor has started to turn on just with that 0.7 of a volt. And you see the current 6 milliamps DC. So we're at 6 volts here. We've got 10 milliamps base current. We've got 1.13 amps flowing through the collector emitter junction. Now I know this bulb on the positive supply rail draws roughly 1.5 amps, so we'll leave it there. I've got 10.2 volts on the base, 14 milliamps on the base current through this 2.2 ohm resistor, so 14 milliamps of base current and 1.5 amps on the collector emitter current. So we've got 1.5 amps flowing through this 0.47 ohm resistor supplying the bulb. Now, as I previously said, this power supply does not like the reverse being stuck up it when I connect it here. Now disconnect this. Right, what I've done, I've got rid of this power supply, so ignore that now. We've got -10, +10. This current meter is now connected to my bulb, to the ground point. So if I now bridge this 2.2 ohm resistor to the 10.5 volts, you will see we've got plus 1.5 amps flowing through this emitter resistor to the bulb. Take the resistor off. Current should drop to nothing, but this meter, something wrong with it, stays on 1 or 2. But now this -10 volts here, if I connect this 2.2 ohm on a base, this is the PNP. It looks the same, but if you look at the current plus my power supply, it's not terribly accurate. So we had 1.5 amps flowing in one direction. Now I've connected this PNP, we've got current flowing the other direction. So minus 1.47 amps. So that minus 1.5 amps rounded up is coming from the 0 volts through the bulb and being pulled down to our -10 volts. Hopefully that demonstrates it. So plus 1.5 amps, negative 1.5 amps. These emitter resistors, they're often overlooked. You'll find them usually on every single output transistor, and you can double these up. You can put another 2 in, then another 2 and another 2, followed by 2 more resistors on each transistor. What happens on this amplifier when you turn up the gain? The current from your plus and minus rails are coming through the collector emitter junction out to your speaker, so push and pull. As the current increases, the voltage drop on this resistor increases, and it's often overlooked. As the current increases, the voltage increases. If this voltage here starts rising, all of a sudden your base to emitter voltage is going to have less of an effect. It means the more you turn it up, the higher the voltage this becomes here. Between here and here you get a voltage drop. The higher the voltage, this transistor starts turning off. So you effectively start losing gain. And the same here. As you increase the voltage here, the difference between your base and emitter has just fallen since this voltage across this resistor has risen. So these actually form a negative feedback. The more current you draw, the less the transistor conducts. They are also known as degeneration resistors, and that's because of the effect as you turn up the current, you start generating a higher voltage across them, and the base emitter junction falls, dropping your gain. Often overlooked. I thought I'd mention that. I mentioned in the previous video that these are biasing, but it actually looks like they're a clamp to stop the base emitter junction going over 4 volts, or certainly when it reaches 4 volts, this 3.3 Zener there and there is going to start conducting. So before I go, let's work out what gain we had. So we had 14 milliamp base current and a 1.5 amp collector emitter current. So 1.5 amps divided by 0.014, so 14 milliamps, equals, that's saying that's a gain of 107. So this was a video introducing you to the emitter follower current amplifier and a push-pull output stage on a high power amplifier. Hopefully you've learnt a thing or two. Thanks for watching.